This video will illustrate how SnapGene can be used to view and annotate DNA sequences. Everything you'll see here can also be done with the free viewer version of the software. First, I'll open a simple text file that contains the sequence of the cloning vector PUC19. I'll click here because PUC19 is a circular sequence. SnapGene displays a circular map with the unique restriction sites highlighted. I can turn the enzyme display on or off using the scissors button on the left. This control would also allow me to change the enzyme set that's displayed, but I'll stick with the current setting. I know that PUC19 contains an ampicillin resistance gene somewhere on the left side of the map, and I'd like to annotate this feature. To find the gene, I press this button to display open reading frames, or ORFs. The ORF I want is the green one over here, so I click to select it. My selection is shown in this bar at the top of the window. To annotate this ORF as a feature, I go to the Features menu and choose Add Translated Feature. This feature was derived from an ORF, so it's automatically designated a CDS or coding sequence. I'll change the name to AMP-R, and I want to change the color to red. The product is beta-lactamase, so I'll type that text here. Then I press OK, and I have a new feature. When I turn off the ORF display, my feature is still visible. I can hide it or show it again using this button. I'd like to annotate another feature, namely the multiple cloning site, or MCS. It stretches between the EchoR1 and Hindi3 restriction sites. In this case, the feature is not a coding sequence, so I can't use the ORF trick, but I can easily spot the MCS by this cluster of enzyme sites. For a closer look, I click on the Sequence tab at the bottom of the window. There are the EchoR1 and Hindi3 sites. I can mouse over an enzyme name to see the recognition sequence. Now I'm going to click and drag to select between the EchoR1 site and the Hindi3 site. Then I'll use the Add Feature command. This time I have a miscellaneous feature that's not translated, and I'll call it MCS. Now I have two features annotated. If I scroll to the bottom of Sequence View, I see the AMP-R feature, which shows the amino acid translation in single-letter codes. I prefer three-letter codes, so I'll click here to change the display. I'd also like to add a primer to my map. I know there's a match for the M13 forward primer somewhere in this sequence. I've already copied this primer sequence from a separate text file, so I'll use Find to search for the sequence in PUC19. There it is. Now I'll go to the Primers menu and choose Add Primer. SnapGene lets me choose to add a primer from the top strand selection. I name it M13 Forward, hit Return, and my primer's been added. When I switch back to Map View and click to deselect, my primer is visible here in purple. In addition to Map and Sequence views, I can use Enzymes View to display restriction sites in either numbers format or lines format. When I switch to Features View, I see the features that I annotated. When I switch to Primers View, I see a list of the primers. History View is empty because this file was newly created. To illustrate how History View works, I'll switch to another file that contains a cloning history. In this plasmid, Sequence View shows me that the EGFP gene was inserted in frame with a hexahistidine tag in the vector. To see how this plasmid was made, I switch to History View, which shows me that the SMA1 HPA1 fragment from PEGFP1 was inserted into the SMA1 site of the PQE81L vector. If I want to examine an ancestor such as PEGFP1, I can resurrect it as a new file simply by clicking on the name. Okay, let's choose PEGFP1. The last thing I want to show you is SnapGene's unprecedented ability to handle large sequences. I'm switching to a file for yeast chromosome 4. This sequence is over 1.5 megabases, which is no problem because SnapGene can open sequences up to a gigabase in length. This chromosome is packed with genes, so I'm going to turn on the zoom function to browse individual genes. I can use the scroll wheel or the sliding window to move along the chromosome. This introduction showed you how to navigate SnapGene files, but the full power of the software lies in simulating molecular biology procedures. The Actions menu indicates that SnapGene can help with cloning, PCR, mutagenesis, agarose gels, and other routine manipulations. Those functions will be covered in other tutorials. Thanks for your attention, and enjoy SnapGene.